Well, hey, everybody, welcome back to the podcast. One of the most hottest topics out there is genetics and understanding your genetics, understanding how your genetics can actually, really understand the insights and how they can impact your diet, your lifestyle choices, like what you're eating on a regular basis, the way that you exercise. That is a really hot topic. And I have got a world expert, Dr. Yael Joffe. She is an adjunct professor teaching nutrigenetics at Rutgers University. She has a PhD in nutrigenomics from the University of Cape Town, exploring the genetics and nutrition of obesity in South African women. And she's part of the team that created the first nutrigenomic genetic test in the year 2000. And she's also co-founded the venture-backed nutrigenomics startup 3x4 Genetics. And this is something that my health coaches actually do. They analyze that with a lot of their clients, really giving their clients a lot of pointers, right? As far as how to set up their nutrition, how well they're detoxifying, a whole lot of factors that go into, let's say, if they have good genetics for histamine metabolism, for blood sugar, for blood pressure stability. It really goes into a lot of detail, and it really organizes it in a way that's very digestible. A lot of the genetic tests out there are just really hard to understand. You get just kind of this raw data. It's very, very hard to understand. And so the 3x4 Genetics I really like because it groups it and makes it very digestible, groups it into categories that we have, a better understanding of. Like, for example, blood pressure, your vascular health, your blood clotting, your histamine metabolism, your mood and behavior, different things like that. And so I really like the way that they organize it and go through it. And, you can actually check it out, 3x4genetics.com. Also, my health coaching team, they work with people all around the world with health coaching, and they use the 3x4 Genetics as well. So you can reach out to one of my health coaches and they can help you get started with that as well. But with that said, Dr. Joffe also has written several books. Her most recent is The Power of Genetics, really phenomenal book that you guys should check out as well. So Dr. Joffe, welcome to the podcast.
Thank you, Dr. Jockers. Thanks for the intro, and very happy to be here.
Well, excellent. Well, let's talk about how you got started, because you obviously are a pioneer here in nutrigenetics and nutrigenomics, and how you really got into this to begin with.
Yeah, it wasn't, I guess it wasn't entirely intentional. It started about I've been in the space for about 22 years now. And I actually started off in architecture, not in nutrition and not in science, and had no interest in fact, in medicine or nutrition and science at the time. But my grand died from cancer. And that kind of led, as happens with many of us in this field, leads us on a journey looking for answers. And I was really, trying to find out why she got cancer, how we didn't know what she could have done better, how she could have prevented it. And this is some time ago. I mean, we're probably talking 30 years ago, where I really had these burning questions and no answers. I mean, there literally was nowhere to go. So, I turned to dietetics, thinking that a degree in dietetics would give me the answers about health and nutrition and healthy eating. Didn't work out like that at all. It didn't take me very long to figure out that dietetics was not going to give me any answers, and it didn't. So I finished the degree, but with great kind of discontent and disillusion about the profession, and continued kind of looking for answers. And I was based in London at the time, and met this extraordinary woman, Dr. Rosalind Garrison, who was a real, talk about visionary. This was in the year 2000. She was a PhD geneticist and specializing in detox. And she had this vision that genetics and nutrition was going to be the future of medicine. Understanding that in 2000, that was way out there. That was she was way out there. And the human genome hadn't been drafted yet. We hadn't, genetics wasn't really in our conversation. We didn't have 23andMe and Ancestry.com. And she was looking for a dietitian. And I said, well, I don't know anything about genetics, but this sounds like something that if I could get to understand it, I could find answers. And so that started my journey. And that's why how I landed up being part of the team that built the first genetic test, and then went back to university to get a PhD in the field. And so I was just, I was lucky to be there right at the beginning, open to the learning. I do well when people tell me I can't do stuff, so I persevered. The first 10 years, everyone was not excited about my career choice. They thought that nutrigenomics was kind of science fiction, that I was limiting my career. But of course now they're like, oh, how did you get so lucky to be in nutrigenomics for so long? So it's been a very long journey. Many genetic testing companies that I've been part of, that co-founded, education companies, teaching practitioners nutrigenetics is really my core love, because it doesn't matter how good the genetic insights are, if you don't know how to use them in your practice and your patients, then very little value. And then finally, kind of my dream company, which is 3x4 Genetics, which you just spoke about.
For sure. And let's talk about like nutrigenetics, nutrigenomics. These are terms that, in the professional world, we kind of utilize almost interchangeably, but there is a little bit of a difference in the meaning of them, and it's important to understand. So let's talk about that.
Yeah, and it's very easy to be confused, and you're not alone. I mean, even academics don't use them accurately. But I think the important thing is to understand why they're different, because actually it speaks to another world of difference, which is genetics and epigenetics. So when we use the word genetics, whether it's nutrigenetics or genetics, we're talking about sequence, the code of our DNA, the spelling. I always use, like it's a language of DNA, and it's made up of letters. And we have all these kind of spelling changes in our DNA, and it's these change in our letters, these spelling changes that determine why we're different from each other. So it's like 0.1%, our code is different from each other. And it's the difference in code that'll determine who we are in this world, how we respond to the world around us, how we respond to the food we eat, the supplements we take, the exercise we do. But even more, how do we respond to trauma, to stress, to all the things that are happening in life, is determined by our inheritance and these what I call spelling changes. And we'll talk a little bit just now, because we use words for them like gene variant and SNP and polymorphism. And then in some places in the industry, they use this horrible word, which I really detest, which is mutation. So we'll talk a little bit about that just now, about why we shouldn't be calling them good and bad. But basically, these spelling changes determine insight, understanding ourselves, know thyself, like, why am I different? But nutrigenomics, when we use the word omics, not ethics, like genetics, now we're talking about something different. We're talking about gene expression. How do we switch genes on and off? Because everything that happens in the body is actually driven by switching genes on and off. Because when we switch on a gene, we make a protein. And remember that proteins are enzymes and hormones and neurotransmitters, the brain messages. And when we switch off a gene, we shut down that protein and we're not making it anymore. So now we've got two halves of the equation. The one is, who am I and how do I respond to the world around me? Insight. And the second part, I talk about the concept of action. Knowing who I am, what choices am I going to make? And this is obviously where your work comes through. What choices am I going to make to be able to optimize the way my genes are switching on and off, to be able to having the right genes, making the right proteins, the right time in the right part of the body. And so this is where those kind of, what I spoke about, really my gran, when she died from cancer, when I was looking for answers, why did she get cancer? So why did she respond? She was taking antacids for years. She didn't have the healthiest diet. Why did she respond to her environment like in such a way that she kind of got cancer? But what could we have done to prevent it? What foods and supplements and lifestyle interventions could we have done with her to switch on more defense genes and kind of switch off more of the pro-inflammatory kind of pro-oxidative stress, et cetera, genes? And so this conversation between nutrigenetics, who we are, insight, and nutrigenomics, gene expression, is really why genetics is so powerful. Because it used to be that, in fact, the first 15 years of my career, all I spoke about was gene variance and SNP.
Yeah.
And now what I really love talking about is the power of nutrition, and this is where food becomes medicine, to really change our gene behavior and gene expression, and then the body heals itself.
Yeah, for sure. And I think the more that we're learning about, these polymorphisms, these genetic polymorphisms, we're realizing that, there was advantages to having these adaptations. Our ancestors made certain adaptations, and there are certain advantages to them. Although those advantages may not always be well suited in our current environment, there are actually advantages to them. And that's why, we don't really want to look at them like they are mutations or something along those lines, but they actually, in some cases, have survival advantages associated with them. I know that one of the most common polymorphisms that is looked at out there is MTHFR, right? That's one that most people, especially, well-educated people and professionals out there, have probably heard of. Let's talk a little bit about that one.
Yeah, so I will talk about MTHFR. I just want to, just concur, totally agree with you, that genetics is evolutionary biology. Genetics and those spelling changes, those polymorphisms, really is about evolution. Why we responded to the world around us is because we were hunter-gatherers living on the plains of Africa. We were eating, hunting an animal every now and again. We had to store as much food as we had to. We were living off legs, roots and berries that we were finding on the ground. So the problem that we're having, and we'll talk, I promise I won't forget about MTHFR, is that the reason we have so much chronic disease in our environment is because we have a complete disconnect between our evolutionary DNA and our current diet and lifestyle exposure. So DNA doesn't change quickly. It changes over thousands and thousands of years. So these polymorphisms don't happen today and then you've got another one tomorrow. They take thousands or tens of thousands of years. So we haven't evolved our DNA to the modern Western diet and lifestyle of toxin exposure, refined carbohydrate, high fructose corn syrup, sugar, alcohol. We're still kind of ancestral DNA, but our lifestyle has changed. And so most chronic disease, almost without exclusion, can be understood in the conflict and the disconnect between our ancestral DNA and our, so I just wanted to agree with you and just
absolutely. I think that's
it's a great conversation.
I think that's so important because, and I want to come back to the idea of how our genetics are actually going to influence our satiety, our hunger levels, our cravings, things like that, and how certain genes may predispose us to more of those things, but those may have been survival traits, right? And they had a survival advantage in the past.
They definitely did. And even we talk about ApoE. So ApoE is one of those genes that is extremely common. It's always in the media. It's, has a lot of controversy around it. Now, ApoE is one of the greatest ancestral genes that we know of. And in fact, I don't know if everyone knows this, that when we talk about ApoE, we talk about ApoE 2, 3, and 4. It's just because actually when we do a genetic test, there's 2 different variations we get, and we put them together and you're either 2, 3, or 4. And there's a lot of drama around this ApoE4. Everyone, it's associated with Alzheimer's and memory loss and dementia. But actually the really interesting thing is that ApoE4 is the ancestral version, the common version. So often we talk about the common version and then the variant, what came later. But in ApoE, the common version was E4E4. And like everyone thinks that E4E4 is like the baddie, but actually E4E4 was common and E2 and E3 came later, much later in the evolution. And so why would a gene that was so common now become the harmful version? Is because it is a pro-inflammatory gene. And at the time of being hunter-gatherers, when you were hurt or attacked by an animal or cut yourself, you wanted your inflammatory system to be able to be really acute and active in healing. And so it was, if you were super responsive, and we always talk about the E4 isoform as being a super responsive, it kind of responds really well to good intervention, but it responds very badly to bad intervention. you would heal really quickly. But now that's not the issue. The issue is this kind of low-grade inflammation that is causing a lot of disease. And so suddenly ApoE has been turned on its head. And so this is a perfect example why I really, really use the word hate, but really hate the word mutation. Because there's no difference between a polymorphism and a variation and a mutation. It's a spelling change. It's one letter that's changed in your sequence. And whether it's negative or positive, it is determined by the environment that you're in, the diet you're eating, and the lifestyle that you've chosen. So, I always say, please don't bring a value judgment to the variance, because even in ApoE4, when I see patients with E4, it's not, I often think, like, we used to call it the dietitian's best friend, because people are super responsive when they've got E4. If you have an E4 patient and they have high cholesterol, you're more likely to get their cholesterol down using diet and lifestyle and supplements than if they had an E2, in which case they might need a statin. So there is like positive understanding in every single variant. So in PHFR, we can find.
I think that's really fascinating with the ApoE4 being so responsive to inflammation, right? And turning up inflammation. We know that, our ancestors, most of them died actually from infections that would get in from flesh wounds, get into their bloodstream, spread into their nervous system, create meningitis or pneumonia in their lungs or something like that. So having a hyper-responsive and responsive inflammatory system was very advantageous, because is actually what the body used to protect against some sort of infection from killing us. Today's day and age, we're not really at risk. I mean, it's very rare, unless somebody's very immunocompromised, elderly, something like that. You very rarely hear about somebody dying from, pneumonia, as a whole, right? Or meningitis, right? Typically we're able to treat these conditions, but this chronic low-level stealth inflammation over time really damages the organ systems, leads to cardiovascular disease, neurodegenerative conditions, diabetes, all these types of issues. And so that's really what we're dealing with now, is kind of this low-level stealth inflammation. And so that variant is no longer advantageous like it was for our ancestors, no longer advantageous for us now. And it's also interesting that you said, the variance is really just one sequence change, like one difference in one letter, like a guanine for, an adenine, right? Or something like that. But when you have that, it can speed up, the function of an enzyme or slow it down. So it kind of alters the way the mechanism and the metabolism of that specific enzyme or whatever it is that you're looking at. And that's really what we're looking at, is how, because a lot of these genes you're looking at are coded for enzymes, right? And these enzymes are carrying out, different kind of metabolic functions. And so you're looking at the speed of how that works, right? How well they break down a neurotransmitter, or how well they, respond to a hormone.
Remove a toxin, or respond to it, but convert a hormone, correct? All those kind of things,
That's right. And I think that's important to know, because most people don't really understand what it is that we're actually looking at when we look at that.
So this brings me back to my favorite word, which is insight, is that we're trying these spelling changes, these one letter change something about biochemistry. So they change something about the way our body is working. And you're right, it can speed up an enzyme, it can make it faster, it can make it slower, it can make more of the enzyme or less of the enzyme. It can even move where the enzyme works. I mean, SOD2 will move the enzyme out of the mitochondria to work outside of it. So it's by understanding the biochemistry of these genes. Now, I have to say, though, that the one thing we must always remember is that these gene variants are very insightful about biochemistry, but there's something that they're not. So first of all, they don't tell us what disease you're going to get, right? These are not disease genes. We don't like using, and there are genetic testing companies will say this gene variant will give you diabetes. This gene variant, that's not the area we're talking about. We're talking about lifestyle genetics, right? The other thing to understand is that by themselves, they're not that powerful, these spelling changes. They do not cause disease. They do not, result in an ultimate. What they do is alter the way the biochemistry works. And the one thing we do very differently at 3-4 is because these spelling changes by themselves are not that powerful. We group them together. So when we talk about, so MTHFR, it brings us a beautiful segue into the conversation of MTHFR, because what happened with genetics is when the Human Genome Draft was kind of launched in 2003, there was this big dream that genetics would change the future of healthcare. And we have done quite a terrible job of that, really. Genetics has not achieved it. One of the reasons being that, as often happens, the commercial market hijacks the science. And what we found is that a whole bunch of companies were taking single gene variants, single spelling changes, like the MTHFR one, and I always say, like, putting it on this massive pedestal, making a whole company out of it, multiple websites, and then selling a whole bunch of supplements for this one MTHFR gene variant. And you know, MTHFR is a great example of what we shouldn't be doing. So first of all, I've heard it called a mutation. I've heard it called a defect. I've heard people, I had someone yesterday send me an email saying, I have the MTHFR disease. So it was completely blown out, like it was just insane. So people were saying, oh, if I have the spelling change, I need to take, 30 supplements. I'm gonna have, autism and, cancer, dementia. But we completely lost the plot in the industry, because remember, it's just one spelling change. And in this area called methylation, where the MTHFR enzyme really plays a role, there are many, many enzymes, not just MTHFR. And where we gain real true insight is when we look at how many of these gene variants are impacting the whole pathway and trying to see whether the pathway is working optimally or not. And this has been, for me, like my kind of soapbox for the last 4 or 5 years, is that we cannot simply evaluate a person based on a single gene. We can't even evaluate the person based on genetics alone, because even genetics by itself is just one piece of information, but that's the problem with kind of 23andMe. They don't know who you are. They don't have you and your health coaches asking questions about what their history's been, what they're suffering from, what their pain level is, what their goals are, doing blood tests and finding out what's going on. Like, so one of the problems of issues, so it doesn't mean MTHFR isn't insightful, it definitely is, but by itself, it is not a genetic test.
Yeah, absolutely. So it's really just giving you raw data, but again, you're not actually, it's not really, there's not a clinical application to it. And that's what I love about what you guys do, is you group a whole bunch of different genes that have kind of similar functions together, right?
That's right.
And put it into a category that is better understood. For example, like histamine, right? And this is a common thing that, we're seeing with a lot of people not metabolizing histamine very effectively, which can predispose them. Some of these individuals have more struggles with seasonal allergies. Some of them struggle with certain foods that they eat that may be higher histamine. And they can have genetics that predispose them to this sort of an issue. So that's something that's like a grouping. Methylation, which is where MTHFR would be grouped into, but there's many other genes that are associated with that. So you group them all into a category, and then, your testing looks at it and then says, okay, you're at higher risk for issues with methylation. So you need to, you should be looking at things like this for your diet, right? Eating more dark green leafy vegetables to support folate levels and things like that. So how were you able to go through this? Must have taken a lot of work to really categorize all these different genes into these different categories.
Yes, it did. So this was the foundation of 3x4, is when I realized that you couldn't just give advice, a diet recommendation, a supplement recommendation based on a single SNP. And then you ask yourself the question, which actually is the most important question if you're building a genetic test, is what is the criteria for deciding whether I'm going to include a gene variant or a polymorphism in a genetic test or not? And up until then, in my whole career, I sat down and I thought, well, how have I done it all these years? And I was like, well, I read the literature and then I get to know the gene variant really well. And then I decide whether it's really good and I put it in the report. And I'm thinking, that's not good enough. Like, That's not scientific rigor. So one of the things we did differently at 3x4 is we built something called Darwin, and it's called Darwin. It's a methodology because it's based on the idea that only the fittest genes survive. In other words, only the best genes will make it into the genetic report. And we built a set of very transparent criteria and a kind of a quantitative measurement that said, was based on two very well-known criteria that is in the scientific literature, which says scientific validity and clinical utility. So basically asking the question, is the science good enough? So does this gene variant appear in the science multiple times? Is it in good scientific journals? Are the statistics good? Did they get the same result for multiple studies? Is the science good enough? And then asking the question, clinical utility, but will it make a difference clinically? Because you can have great science and it can appear in thousands of articles, but when I actually need to use it with my patient, it doesn't provide any clinical insight. So I always like the final question. So we have 8 criteria built into Darwin, but really the most important one is, will knowing this information in my genetics help me make a better and different clinical treatment decision? Because to your point is that you keep on saying is that if it doesn't change your decision making, you're just selling data. It's just data.
Right. Yeah, that's so important to understand. And, we also know that the environment that we're in is also going to play a role in how the genes express themselves. So our epigenetics, or the environment that we're in, our level of stress, perhaps what nutrients we're getting a lot of in our diet, what we're not getting a lot of, our sleep habits, all of these things are also going to play a role in how these genetic variants express. Is that correct as well?
Yeah, so not just in the genetic variants, but the genes. So we talk about how genes express. And, it used to be believed that, or understood that it was like, certainly the food we ate, or if there were radiation or toxins, that it would change gene expression. Now we are starting to understand. And remember in the beginning, I said, nutrigenetics and nutrigenomics is about changing gene expression. But actually what we're starting to understand now is absolutely everything that happens in our environment changes gene expression. So you mentioned a whole bunch of them and you were spot on, sleep, stress, but it's even more than that. It's about connection, relationships, a hug, laughing. We talk about cold water immersion is huge when it comes to changing gene expression. Meditation changes gene expression. So now all these things that we've been advocating in the kind of more integrative lifestyle medicine space, we're starting to understand the science, because we always said, meditation is really good for you, but we couldn't show the science behind it. Now we actually know that what happens in the body when you meditate, and it's actually about switching on and switching off genes, which helps heal the body and heal the nervous system and change the way your brain's functioning. So it's been amazing and that's why the world of nutrigenomics per se has now grown in what I prefer to call kind of lifestyle genetics, because every single decision we make, every minute of every day, is going to influence how our genes are switching on and switching off. And so it's not something we can put off for tomorrow, or put off for next year, or put off, for next month.
For sure. And I know the 3x4 genetics will go into things like, for example, how you exercise. So let's look at some examples. Like, what are some, maybe 1 or 2 of the genes that impact the genetic variants that can impact the way that you exercise, and how your system personalizes and gives personalized recommendations for exercise based on those variants?
Yeah, so in exercise, it's actually an area that we're starting to specialize in. We have a whole team just in sports genetics. And what's so interesting about it, and this doesn't matter if you're on the couch and just want to get off the couch and start moving and maybe walk a 5K or run a park run, or you're an elite athlete kind of in a really professional sports team, it's the same conversation. So what we found is that we always look at what is the contribution of genetics. And amazingly, in sports and fitness, genetics has a huge contribution, like well over 60%. So that means that if you're an elite athlete, you're there because at least 60% of what you're doing is coming from a wonderful inheritance that you got from your parents, and the rest is your training and nutrition and everything. And the areas that we look at is things like injury susceptibility. So we know, especially with professional sports teams, that if your players are not on the field, you're not running a good franchise, right? You got a problem.
You're not going to be successful. Yeah.
You're not a success. So injury susceptibility is one of the most things. And the most is, how do we predict when someone's going to be injured so that we can prevent it, change the training, give them recovery. And we've been able to pinpoint injury to the point now where we can even look at subcategories of injury like rotator cuff and ACL and stress fractures, so that we can plot when an individual's training load is almost getting started. So one thing is injury. The other thing is recovery from training. So I'm one of those people, I can train 5 days a week, but I can't train 7 days a week. If I do that, I don't recover, I don't get fitter, I don't get stronger, and I get injured. So some of us need more recovery. So we know that there's certain processes like inflammation and oxidative stress that are going to impact how we recover. And then I talk about like potential, exercise potential. You know, when we talk about, I'm one of those people who's training for a half marathon, and I have to, like, if I haven't been running, I've got to start at 2 kilometers or 2 miles and then 3 and build up slowly. Whereas I have friends who, you know, just rock and roll straight into 5 miles. So what is my potential for training? What is my baseline, my VO2 max baseline? Am I going to be a podium or am I going to be mid-range? And also, you know, if I've got 3-4 hours a week to exercise, where am I going to use those 3-4 hours? Because if I'm exercising in my comfort, so say I'm more endurance-based genetically and I'm doing more distance kind of training, I'll be much happier than being in a gym doing power training. So some people genetically are really, really well suited to do power training, muscle work, like they just thrive in it and their body responds. So it's understanding all these more elements, and it's not only for the elite athletes, because if you just get off the couch, we want to make sure we use your time to the best we can, because most of us are so busy that exercise time is actually a great luxury in our lives. So let's make sure we use it in the best way, where your body's going to respond as much as possible, and we're going to keep you from getting injured. So that's a perfect example of how genetics can be so insightful.
Yeah, very insightful. And I know I had my genetics tested with you guys, and I was very high in the injury category. And that's something I've always really tried to work on ever since, you know, I was an athlete, you know, throughout high school and whatnot. But ever since I got in my professional career, I exercise regularly, kind of like you. I do best with about 5 days a week, 2 days of rest, but staying active and moving every day, which is easy for me because I've got young kids. And so chasing them around and things like that. But, you know, as far as injuries go, I always stayed away from doing CrossFit and although I do resistance training 5 days a week, I lift weights, I do, you know, squats and bench press and things like that. I stay away from powerlifting and like really explosive kind of power cleans and things like that, because I always felt like they were tough on my wrists, tough on my joints, and just kind of intuitively, I said, you know what? I feel like if I'm doing this regularly, that I could get hurt. And so intuitively, even though, you know, CrossFit was all the rage, you know, 5 or 10 years ago, and I mean, it still really is. I've always stayed away from it because I just feel like a lot of those exercises are a little bit too hard on the joints. And I feel like I just intuitively knew that I was more injury prone. And, you know, lo and behold, genetically, I'm very high in that injury category. So I do need to be very careful in the way that I train. So very interesting insight there. Also, my collagen and joints, looking at, because you break it down into different systems as I'm looking at this. And guys, I'm actually going to invite Dr. Joffe back, and she's going to actually do in a future podcast, she's going to go through all my genetics, all my systems. So we'll go into a lot more of this. You guys will really be able to see it. But I wanted to let her know that I'm also very high in when it comes to bone health. So I'm at risk when it comes to bone health, and also collagen and joints, and histamine overload, which can play a role with joint structure as well. Like, for example, people with like joint hypermobility, like Ehlers-Danlos syndrome and stuff like that. There's an issue with mast cells and histamine that's associated with that. I don't know if you've heard of that, but histamine can play a role with joint issues. So it seems like I've got a lot of these higher categories associated with joints, associated with bones, collagen structure. So let me know. That's something I really need to pay attention to, making sure that when I'm exercising, I really want to make sure I've got great form and, doing everything I can to help prevent against injury and giving myself proper recovery time, proper nutrients to support recovery. So that's something I really took away from it.
Yeah, and that's absolutely spot on. It's not, we're never saying don't do something. We're never saying don't make that choice. It's about, as you say, like, first of all, making sure you got the right ratio of recovery. And we're big fans of active recovery. We don't think that lying on your bed all day is the solution. So recovery in our world is often active recovery. Take the dogs for a walk, play with your kids. But you're right, it's about the prevention. So it's about functional training to make sure that you're taking care of those joints and collagen, nutrition to support collagen. So, knowledge is power. And we always say in genetics, we don't know what we don't know. Now, you were quite intuitive about it, and that also comes from who you are and your profession and the work that you do. You've got such a spectrum of knowledge that you've brought this, but most of us aren't. Most of us don't know what we don't know. And so, we learn by trial and error through having injuries and being and having to recover from this. So it's so insightful. The other area where I've seen this, and you mentioned histamine. It's been amazing. Histamine's been one of the most clinically useful pathways that we have in our genetic test. It was something that was barely even spoken about, and now what we're finding is those that have, the dark purple of histamine, we talk about, migraine sufferers. We're finding people who are like seasonal allergies, gut dysbiosis, and we're seeing histamine. And when we you can take high histamine foods out the diet, we're seeing incredible change. So this is one of the areas where we see the genetics, because that's not something you would guess at. You wouldn't go, oh, I've got high histamine. People don't think of it. So that's been amazing. Histamine's been incredibly insightful for us. And the other one is what you spoke about earlier, which is around, appetite and satiety and why we eat and the way we eat. People always believe that the genetics of weight was all about metabolic rate. I can eat whatever I want and I don't get weight, or I just look at food and I gain weight. And that was like the complete understanding of how genetics influences weight. But now we know it's like way more complex and granular than that. And in fact, I give a whole webinar just on the genetics of weight. And it's my favorite topic, because we never understood, why do some people gain weight so easily and find it so hard to lose weight? And coming from the dietetics profession, where we were so dismissive of individuals who, when we gave them a diet plan, which had reduced calories and increased calorie expenditure, that they didn't lose weight. It was almost like they failed us. And there was a lot of, you were cheating, you didn't listen to me, you don't have willpower, you don't have self-control. And not only from the profession, but from families and friends, and, that the reason you didn't lose weight. So we set up everyone for failure, because we didn't understand. And as we mentioned earlier, the ability to store fat and hold on to it is actually an evolutionary advantage. We would have survived much better on the plains of Africa if you can store what you take in and not burn it up. Whereas now in our current world, it's obviously working against you. So we've discovered this amazing world of appetite and satiety that it's taken me like 15 years to figure out that my appetite is not the same as yours. And how much food I need to feel full is not the same that you need to feel full. And when you start thinking about that, and even within a family, even different children in the same family will experience hunger in a different way. So it's not like greedy, you've got self-control or any of that. It's literally our genes drive appetite.
Yep. And there's some key genes too, like you have your FTO gene, right? For example, I know you probably talked a lot about that in your work, the fat mass and obesity associated gene. Okay. Which is kind of like
I call it the buffet gene.
What do you call it?
Thrifty gene. I call it the buffet gene. I'll tell you why I call it the buffet gene. It's because so if there's an interesting gene that, it's called the fat mass and obesity gene. And the fact that it's called that tells you we don't totally understand what's going on in this gene, right? Because most genes are named after the enzyme. But there have been more research studies on this particular gene in the area of weight than probably most genes. So it's extremely well researched. And the reason I call it the buffet gene is there's a group of individuals who, when they walk into a buffet and they see this amazing food, they have a decrease in the locus of control, in the ability to moderate how much food they eat. So for some of us, we'll take a plate of food, go sit down and we'll eat, and we feel full, and we won't go back to the buffet table. But there's a group of individuals who will go back to the buffet table and back to the buffet table, irrespective of satiety.
Yeah.
And FTO is one of those genes that impact our ability to control the calories we consume. So when you put together, so like FTO with some of the other genes that we sometimes see, even addiction genes, dopamine genes, and I use addiction in a kind of a lighter way, where we look at dopamine driving, which is, reward behavior. I eat carbs and sugar because it makes me feel better and it raises kind of my neurotransmitter. And you put that with an FTO gene, we start understanding why someone is compulsively eating or snacking and binging all the time. So even understanding, fasting, and why is it harder for some people than for others? Well, genetically, some of us are much more likely to be snackers, to eat constantly than to. So for those, it's harder and can take longer to get into an intermittent fasting kind of thing. So it's just so incredible and empathetic when we start understanding who's sitting across from us and what their journey is and what their experience is, and not bringing our judgment from the studies that we did at university that says we're all the same and we all respond in the same way.
Yeah, for sure. Well, I know that I've gotten a lot of great insight from my 3x4 genetics test. It just really breaks it down. And you have all these different pathways that you can look at. And you really break it down in a lot of different ways. Now, 3x4, where did you come up with the name 3x4 genetics? I think that's a great, a great thing to help our listeners understand.
So the reason that so it's actually 3x4, but 3x4 is fine. But the reason I'm here is that before I launched 3x4 genetics, I had an education company, Manuka Science, and I used to teach nutrigenomics to clinicians. And I wanted to come up with a way that practitioners could summarize what they had learned from a genetic test into a one-pager that they could then share with their patients, so that their patient wasn't overwhelmed by how much information we're getting, and that the practitioner was able to really create like a summary of what they've got. And so the idea behind it is, once you evaluate a report, whether it's 3x4 genetics or whether it's another genetics report, you should be able to identify the three most important areas you want to focus on. There's inflammation, detox, histamine, appetite, whatever that is, three most important areas. The three most important dietary changes you want to effect, because you and I know that you can't give an individual 50 different things to do. A confused brain says no. I love that. So what are the three most important dietary changes? The three most important lifestyle changes you can do, and the three most important supplements. And so it's 3, 3, 3, 3, which is 3x4. And that's how the name came out. It is really like, if we can't summarize the genetic contribution to an individual's health in one page, then we either haven't been trained well or we're doing a disservice to our patients.
Yeah, I think that really makes it chewable, makes it understandable for people. You take this data, we put it into different pathways. You can understand where you may have some weaknesses, where your strengths are, and then, lifestyle recommendations based on that, things that are going to help put you in the best position to thrive in life. So I love it. And so for practitioners, guys, if you're a practitioner out there, you want to learn more about this, go to 3x4genetics.com. That's 3x4genetics.com. If you are somebody that's not a health practitioner or a health professional, but you want to get this done, I would highly recommend it. Great thing about this is, unlike blood work, this is not something you need to do every year. You just do it once time, your entire life. It never changes. You have that data, and now you can use that with, everything that you do going forward, any sort of blood work or other labs that you do, you always have that genetic data. So if you're working with a practitioner, that's going to help that practitioner better understand how to take good care of you. So if that's you, guys, you can just go to my website, drjockers.com, under the coaching tab. Okay. we have a section called long distance coaching, and there's a banner in there for the 3x4 genetics. And you can work with one of our health coaches. They will help you order this. They'll actually do it for you, and it will get sent to you. And it's simple. It's not, blood work or anything like that. It's really just a saliva draw, right? So
it's a cheek swab. So you
cheek swab. Yeah. Cheek swab. That's what they call it.
The inside of your cheek. Yeah.
Yeah. Cheek swab. So that's right.
And to your point, your amazing team have been studying with us for a long time, have really gone deep and really become experts in this space, and are just so brilliantly suited to translating this genetic information and making it really, really easy to understand and action. So you have an amazing team.
Awesome. Well, thanks so much, Dr. Joffe. And we will be bringing you back on to actually do a detailed analysis of my results. So you guys will get a chance to understand that as well. My people love understanding more about my own lab work, my blood work, my organic acids tests. So I've reviewed those in the past. And so looking forward to doing the genetic testing as well. So thanks again, Dr. Joffe. Appreciate your time. And guys, we'll see you on a future podcast. Everybody be blessed.